Right, so what we have here is a fairly classic geometric sequence problem where if you read through the question, quite often focus along at the end, we're being asked what is the 11th term. Now they've already given you a clue here when they say geometric sequence. Remember when you're doing these questions, they'll be popping up in your exams and they'll mix up with a whole load of other things. So that part there where it says geometric sequence should get you automatically jumping straight into your formula booklet and actually writing down the formula, the general formula for the term of any geometric sequence, because notice they're asking you for the 11th term. So straight away here, I'm taking out that value because that's basically telling me n equals 11. Now, ideally, you should have a formula you can substitute into. In this situation, we don't, and it's very similar to other problems you might have seen with arithmetic sequences. You're actually told the properties of different terms. So here, I'm going to take this information here, that the 7th term is 13, but on my answer paper, I'm going to write that down in this type of language. So I'm basically taking the information out of the question and putting it into a way where it's just a bit easier for me to work with. Now, this is a classic question where you've got two things. You're given two bits of information that are very similar, and quite often this suggests you're going to end up with simultaneous equations. But what can I do here with these things? Well, I'm going to take this and I'm going to enter this information into that formula there. Now, you have to watch how this actually works, because in your formula, if I put it down here, some people get a bit confused when they're transferring the information in, so watch what happens. This bit here does not go there. That's what a lot of people think when they're using this formula. What actually happens here is, this number, this is the value of that. So what I'm going to do is, I'm just going to put that in for the UN expression. Now, let's go to the other side. I don't know what the first term is, and I don't know what R is, so I've just got to write those in as variables. What other bit of information do I have? Well, in this particular number, n is equal to 7, so that will give me r to the power 6 here. So that's the first bit of information used. Okay, now I'm going to do the same thing with this piece of information here. Let's just make it a bit more consistent. So that piece of information there. So as I say to you again, if I'm substituting into this particular formula here, I start off with that number. That number is going to go into the UN position. I don't know what U1 is, I don't know what R is, but again, now you can see in this one n is 9, so 9 minus 1 gives me 8. So I've actually now got two equations, and you have two things that you don't know. Two equations, two things that you don't know. So you should start thinking in your head, simultaneous, except these do not look like the classic simultaneous equations that you've done before. You're actually going to use a method to solve these, which you have learned before in a different context. I'm going to use the method of substitution to solve this. What I'm going to do is I'm basically going to find these two missing variables, and I'm actually then going to go back and I can recreate this formula, and then once I've recreated that formula, I can then take that power of n and substitute it in there. So that's basically my journey for doing this particular problem. So let's give ourselves a bit of space to work from. So, how do you solve these simultaneously? Well, the one to focus on is the easiest one. You can see you've got a U1 here and a U1 there. So I'm going to substitute, I'm going to use U1 to use this substitution method. So what I do first of all is, I'm going to take this one here and I'm simply going to rearrange it to make U1 the subject of the formula. Now you've all got different ways of rearranging. Some people might say, oh, if I divide both sides by r to the power 6, that leaves me with U1 on that side, and I've got 13 divided by r to the power 6 on the other side there. If that's the way you like working, that's fine. You can just leave it like that. So I've now rearranged to get what U1 is. Now the reason it's called the substitution method is because I'm now going to take this value of U1 and I'm going to substitute it into the second equation. Remember, you need to have two equations with two unknowns. So I can then take that second equation in my working, and and substitute in what we know u1 is equal to. So you can see it here, it was 13 over r to the power 6. So that's simply substituted into the u1 position, and then I have to multiply that by r to the power 8. So that's just an equation now, and you're going to solve it. So using your rows of indices, we can see we can cancel here. We end up with 52 equals 13, r squared. So I'm just going to go through my steps for solving this. Divide both sides by 13, and now I've got the value r. The value r is going to be the square root of 52 over 13. What you have to remember is you've got two possible values, a positive and a negative. Now at this stage, if it's paper 1, you can't use your GDC, so you would leave your answer like that. But even if you use your GDC, if you do the square root of 52 over 13, actually, now that I look at it, 13 goes into 52 4 times, so that's really easy. You don't need a calculator. That's what we've got. But you can't have two different values for the ratio. So if you look at the numbers that you were given there, we've got, what was it, we started with 52 and 13. You can basically ignore the negative value. So what I would be doing next is I'd be saying, r equals 2. Now the next thing I need to find is, what's the value of u1? So coming back to solve it simultaneously, I would then go back, say, to my first equation. So I would now write down, I might, if I've got time, I might say put r equals 2 into, and I get 13 divided by 2 to the power 6. And again, you might want to jump into your GDC and do that, or if it's paper 1, you can't. Now 2 to the power 6 is 64. Now if you do 13 divided by 64, you get a long decimal answer. You don't need to do that. You can simply use 13 over 64 as your first term. Now what that means is we've now got a general formula in that question. We can now go back to the beginning and say, well, the general formula is now u1, which is 13 over 64, I'll just put it inside a bracket, times the common ratio 2 raised to the power n minus 1. And now I can go back and actually answer the original question, because I'll go back to the beginning. They wanted me to work out, which one? The 11th term. So I come back down to my working here, and all I need to do now is, the 11th term is given by 13 over 64 times 2 to the power 11 minus 1, 2 to the power 10. Now looking at that, you'd probably want to use your GDC to get the answer, although I could say, I could work that out, working it out the long way. But you can get an answer, and that's simply how you get the term in that question. Now there is actually another way of doing it. This method that I've shown you here, going back through it, by basically creating, and this is the key bit here, by creating two equations and then solving simultaneously by substitution. That works for every single problem in this category. But if somebody's thinking, you can actually make a shortcut here if you understand how geometric sequences work. Because here's another way of getting the answer. In the question, they told me that the 9th term is 52, and I'm looking for the 11th one, and I've already discovered, when I solved them simultaneously, I discovered what the common ratio was, the number that I'm always multiplying by. Here it is here, r is equal to 2. So if I know what the 9th number is, which they gave me in the question, this is a bit annoying, I forgot it, let's go back and have a look. What is the 9th number? It was 52. So I can basically say, well, if the 9th number is 52, and I've done some solving simultaneously, I can simply take the value of r. If I multiply that by 2, it gives me the 10th. And if I want to get the 11th number, I can simply multiply it by 2 again. So I actually don't need to do the step of finding this thing and then creating this formula. I can actually, if I don't have to multiply too far, I can simply use the common ratio to get the answer. So just be aware that there are two different approaches to getting the final answer there, but The full method where you solve simultaneously and then recreate your general formula will work in every single situation, every single scenario.